This video is in response to a question I got from a user who was watching a prior video of mine called Faster and Easier Parameters. It's one of my most viewed videos on the channel, and if you haven't seen it, you should check it out because it will really save you a ton of time and make your reports more flexible. Link in the video description. But the question was, could someone use slicers to make their filtering choices and have those choices be fed into Power Query as parameters? So let's see how we can have Power Query use slicers as parameters. Now here's the problem. Slicer objects cannot communicate directly with Power Query. They're designed to interact with pivot caches and data tables. So what we're going to do is we're going to have to take a very roundabout way to get the slicer selections into Power Query as a query parameter. So here's the map of what we're going to have to do. Now, I had no idea how to do this when the question was asked, so I had to do a fair bit of research. And it was very surprising to me that I couldn't find anything on how to do this. So what we're about to see is what I figured out. If there is a better way to do this, please put it in the comments because any way to cut out steps is always welcomed. We start by setting our information as a proper data table. This data table will be used to create a series of very small pivot tables, one pivot table per category. There won't be any totals or grand totals or any other aggregations. We're only using the pivot tables to create a list. Those pivot tables will then be used to spawn slicers. So the slicers will actually be filtering the pivot tables. We will then use a little bit of VBA magic to read those slice pivot tables into a second set of tables that Power Query can read. Those tables will be brought into Power Query and turned into lists. It is these lists that we will be able to use as filter criteria for the various columns in the query. Now, if that was a bit difficult to follow, we'll begin with the data table. We'll build a pivot table for each item we want to use as a parameter. We'll build a slicer from each pivot table, build the output tables from the macro, and then use the output tables from the macro as Power Query input tables. So it's a bit of a roundabout journey to get there, but if you're willing to put in the effort, you will end up with something that is actually quite cool. If you want to follow along with this project or just want to go look at the solution file, download the starter file, solution file, and all the embedded documentation from the link in the video description. We begin with a set of data, and I have set this data as a proper Excel table, and we know that because I have the table design ribbon. If you'll notice in the upper left-hand corner, I've named this table tblSales. On the user input page, I've created two small data tables, one titled Start Date, another titled End Date. They only have one column each and one row each. The start date will hold the user's input start date, and the end date will hold the user's input end date. Notice the names I've given these tables, SEL Start Date and SEL End Date. We will use those names later during our workbook discovery phase. We'll now take this data table and create three small pivot tables in this area here. These pivot tables will drive the slicers. So we'll go to Sales Data, Table Design, Summarize the Pivot Table. I'll use an existing worksheet, browse out, and I'm going to point to this cell right here. I'll add product and do a little customization. I'll give it some color, no subtotals, no grand totals, tabular form. We'll do the same thing here for the region and the supplier. Sales Data, Table Design, Summarize the Pivot Table, point to existing location. I'll click here. This will contain region. We'll do our customization, give it color, no subtotals, no grand totals, tabular layout. And now the supplier. Back to the data, Table Design, Summarize the Pivot Table, existing worksheet. I'll put it here. Hit OK. We'll give it supplier, and then do our customization. A little bit of color, no subtotals, no grand totals, tabular layout. When we get to the part of using VBA code to loop through these pivot tables to pull their contents, we need to know which pivot table we're looking at, and we'll do that by the name of the pivot table. Now the names are incredibly unhelpful. Pivot table 5, pivot table 6, pivot table 8, whatever your numbers are. So let's give these better names. So with the product pivot table selected, I'm going to go up to the pivot table name field and name it PT Product. For the region, I'll name this PT Region, and for the supplier, PT Supplier. Now that we have our pivot tables, we can build our slicers. So I'll click on the pivot table for product, go to pivot table analyze, insert slicer, and I'll choose product. And we can see when we work with this, it filters that particular pivot table. I'll give it a matching color, stretch it out. Next, we'll click on the region pivot table, go to pivot table analyze, insert slicer, and we'll select region. I'll move it, color it, and size it. Lastly, we'll click in the supplier pivot table analyze, insert slicer, and we'll pick supplier. We'll move it, color it, and size it. I want these 3 slicers on the user input page where the user selects their date range. So I'll select the headings of each of these slicers. I'm holding down Control. I'll cut them, go to user input, and paste. Now I can drop them in their final resting positions. Now that I've tidied up my screen, to test this, if we were to choose Baseballs, Central, Athlete Stream, if I look at the selections page, it's Baseballs, Central, Athlete Stream. If I select multiple products, multiple regions, and multiple suppliers, on the selections page, I see those listed. I'll go back and clear the filters for each of these slicers. Now we can use these pivot tables and with a little VBA code, extract the contents from those pivot tables and put them into proper tables that we can then pull into Power Query. To add the VBA code, we need to get into the Visual Basic Editor. Hold down the Alt key and press F11. In the Project Explorer on the left, we need to import the VBA code I've written for you. Now, if you don't have this Project Explorer on the left, go up to View and just choose Project Explorer. This will be a list of all of your open workbooks. On any item in the current workbook, we will right-click and say Import File. Browse out to the Process Slicer Input.bas file, click Open, and you will now have a Modules folder, and when you open that up, the Process Slicer Input module. When you double-click that, here is the code. I have tried to put as much documentation into this code as possible, so if you do understand a bit of VBA, this should make some sense. If you don't, that's okay. You don't have to understand this, you just have to know how to point to it. We'll close the Visual Basic Editor. When the VBA code executes and reads the contents from those pivot tables, it needs some place to put the results. So we're going to create 3 small data tables, one for each of the VBA outputs. We'll make one for product, one for region, one for supplier. We will give these 3 tables some temporary information, just so it has structure. Now we turn these into proper data tables. So I'll highlight the product table, Control-T, Enter, highlight the region data, Control-T, Enter, and the supplier data, Control-T, Enter. I'll change their colors. These temporary ABC entries will be replaced when we execute the VBA code. When the VBA code iterates through the pivot tables, it's looking at the pivot table's names. It needs to match that name to the output table. And right now my output table for product is just named Table 2. So I'm going to rename that to SEL Product. For the region table, I'll name that SEL Region. And for the supplier table, I'll rename that to SEL Supplier. It's now time to test that code to see if it works. I'm going to build a launch button to execute the code. I'm going to go to Insert. I like icons. And I'm going to do a search for the word run, and I'm going to pick this running gentleman. To assign the macro code to this icon, we right-click and choose Assign Macro. The macro we're looking for is the one that says Write All Slicer Selections, User Input to Selections. I'll click OK. If we click away from the icon, now when we hover over it, we can see the little Microsoft giving us the finger logo. We'll give it a click, and there are my populated output tables. Now the real test is going to be to go back to the user input page, make some slicer selections, and now see if those slicer selections will be brought back over to these output tables. So I'll click the little man, my tables update. Back to user input, I'll select 1 entry each. Back to selections, click the man, 1 entry each. Clear the lists, back to selections, click the man, full lists. And now it's time to bring these 3 tables into Power Query so we can set them up as lists and use them as parameters for filters. To build these queries dynamically, I want to ensure that I bring in every possible table that I'm using as a filter. What we'll do is we'll start with a blank query and write a command that will scan this workbook and list every usable thing that Power Query understands. We'll start by going up to Data, Get Data, From Other Sources, Blank Query. If the formula bar is not visible on your screen, go up to View and check the box in the upper left for formula bar. In the formula bar, we'll type in an equals EX, and I'm going to use an Excel.currentWorkbook function. Open close parentheses, hit Enter, and this gives me a list of everything in the workbook that it understands. In the content column, we have a list of nested tables, and if we peek inside of these tables, we can see tblSales is my starting data. I have my start date field, my end date field, the list of products, the list of regions, the list of suppliers. These other items are things that it cannot process, and I don't want those. Now, to make sure we don't get any other types of objects like other named ranges, I'm going to perform a little filter on the name column, and I don't want anything that has an exclamation mark in it or an underscore. Now, I'm going to filter for both of these separately just because there could be other objects that show up later in your workbook that only have the explanation or only have the underscore. So I'll do a text filter, does not contain, and I'll say does not contain exclamation mark and does not contain underscore. I'll hit OK. I'm going to rename this query to inputs. I've already created my query folders for organization, and at this point I can drag and drop these into their requisite folders. But if you don't have these folders, you can right-click on a query and create a new query group, and then just give it whatever name you want to give it. I like this particular naming style because it represents stages at which the data will flow through the system. So I'll put inputs in my table discovery folder. So the very first thing I do is just discover the tables in the workbook. Next, we want to extract the data from the tblSales table. And if we peek into that table, we can see all of this information. So what we'll do is we'll start a blank query that will point to the inputs query and get the information from the content column first row. Now remember, Power Query starts counting at 0, so the first row is going to be 0. I want this query to be stored in the second query folder called Get Data, so I'm going to go ahead and click that folder. That way when I create this next query, this is where it will be placed. I'll right-click, New Query, Other Sources, Blank Query. The name of this query will be called Sales Data, and in the formula bar, we'll type in equals inputs, and we want to point to the 0th row. And whenever you refer to a row, you have to place it in curly braces. So I'll type in 0, hit enter, and this returns the first row of the inputs query table. Since I only want the contents of this table, and if I click next to it, I can see the information, I'll click on the table hyperlink to extract that information as a new step. This will extract the data and set the data types. The one thing you might want to do is refine the data types because sometimes it's not as accurate as it should be. Like in the case of the date column, I don't need date time information, I just need date information. Scanning over, cost and sales, I'm going to change their data types to currency. It's now time to gather the user's selections, the start date, end date, products, regions, supplier choices. Looking back at the inputs query, we have a series of tables for all the user's choices. We have their start date, their end date, their selected products, selected regions, and selected suppliers. So how do we get each of these into separate queries so they can be used as parameters? I'll go to my user selection folder. In the empty gray area on the left, right-click, New Query, Other Sources, Blank Query. For the formula bar, we're going to type equals and point to the inputs query, and the start date is on row 2. So when we want to point to a row, we put curly braces, and remember we start counting at 0, so row 2 is really entry number 1. Hit enter. If I click next to the word table, I can see that start date. I just need to extract it. So I'll click the table hyperlink, and I'll refine the data type to just date. I'll rename the query to start date. Let's do the same thing for the end date. Right-click, New Query, Other Sources, Blank Query. In the formula bar, equals inputs, curly brace, and we want the second row from the inputs query, which is really row 3. That's the end date. We'll click the table hyperlink, refine the data type. Rename the query to end date. These start date and end date query entries can now be referenced by other queries, so we can use them as parameters. Let's now do the same thing for products, regions, suppliers. Right-click, New Query, Other Sources, Blank Query. In the formula bar, equals inputs, curly brace. Products is on the 4th row of the inputs table, so that's going to be position 3. Hit enter, extract the table, rename the query. Right-click, New Query, Other Sources, Blank, equals inputs, curly brace. We want the 5th row of the inputs table, which is position 4. Extract our table, rename the query to regions. Our last user selection extraction, right-click, New Query, Other Sources, Blank Query, equals inputs, curly brace. We want the 6th item from the inputs table, which is position 5. Extract our table, rename the query. The catch is we cannot point to these queries and use them as filter criteria because filter criteria expects a list. And these are not lists, these are tables. One way to convert these into a list is to right-click on the heading of the column and choose Drill Down. That will turn this into a proper list. Notice the icon changed. It's a list icon instead of a table icon. I'll go to Regions, do the same thing, right-click Drill Down, and then Products, right-click Drill Down. We don't need to do that for the start and end dates because these are just single item tables, which are basically lists by nature. But since you can't read an entire column of a table in as a list, it had to be converted to a list. Now the really fun part, reading the sales data table and filtering it for start date, end date, products, regions, and suppliers. In my folder called Query Output, I'll right-click in the empty gray, New Query, Other Sources, Blank Query. For the first step, I just want to point to the sales data query. So I'll type equals # sales data. Hit enter. I'm now looking at the sales data. I always find it easier to start with filtering very statically, let the system write the code for you, then go in and just modify that code to make it dynamic. So the first thing I want to do is filter for a date range. So I'll go to Date Filters, Between, and I'll just pick some arbitrary date like January 1st, 2023 through December 31st, 2023. Looking at the M code, we can see that it's going to iterate through each row, checking to see if the date field is greater than or equal to this constructed date. I want to replace that constructed date with a pointer to the start date query. Now, if we go back and look at the start date query, the query is called start date, the column name is called start date, and we have an entry in the 0th position, the first row. So we have to point to the table, the column, the row. So let's replace this static entry with a pointer to the start date query, then in square brackets, the start date field, and then outside of those square brackets, curly brace 0. Before we do the end date, let's make sure this works. I didn't get any errors, I have dates. Then it looks for the date field to see if it's less than or equal to this static date. So let's take this static date and replace it, # to the end date table, square bracket, end date field, outside of the square brackets, curly brace 0. I'll give it a check, and all appears to be working. For the products, we will temporarily filter for a single product, baseballs. Now you can see the product column has nothing but baseballs. But we're going to replace the static examination of the products column for that one product with a function that will look through that products column and keep anything that is in the list from the products list in the user selection. So after the each, we'll delete what we have, and we will replace that with the list.contains function in parentheses. So for the first argument, it needs a list. That will be the products query list, comma, which column am I scanning in this particular table? So that will be square brackets, the products column. We'll hit check. Let's scroll over and do the same thing for region and supplier. We'll start with a static declaration of just a single region. We'll then replace this static declaration, region equals central, with a list contains function. We'll point to the region's query, that list, and it will be exercised against the region column of this table. Finally, the supplier. We'll filter for a static supplier, replace this static declaration with a list contains function, point to the supplier query, comma, and then square brackets, the supplier column. Let's rename these steps so they're a little more understandable. We'll also rename the query to process data and selections. I don't want to send all of these queries as output back into Excel. The only one I want is the process data and selections query. So we'll temporarily send everybody out as a connection only, then we'll change the final query to produce a proper table. So we'll go to the lower part of close and load, say close and load to, and we're going to set everybody up as a connection only query. In our queries and connections panel on the right, I'm going to scroll down, right click on the process data and selections query, choose load to, and tell it to load to a proper table on a new worksheet. Here's my output. Now the real test is going to be to go back to the user input page, select something like baseballs, central, athlete stream, but maybe only for 2023. So January 1st, 2023 to December 31st, 2023. We'll go back to selections, click our little man to update our slicer tables, go back to process data, right click refresh the table. And there we have baseballs, central, athlete stream, only for 2023. Back to user input. If I choose gloves, Southwest tennis joint, and we'll change this to 2024, I'll go to selections, update my filter tables, go back to process data, right click refresh. 2024 gloves, Southwest tennis joint. Because we have to run two separate updates, one to update the query parameter input tables and one to update the actual output table, I've created a macro here called run all. And all that does is execute the macro that updates all of the Power Query parameter tables and then runs an additional step to refresh the output table. So we could just use the run all macro to do everything. So back over here on the output table, I've pushed the table down a little bit to give myself some room. I'll go up to Insert, Icons. I'll do a search for Run, add my little running man. We'll right-click on the icon, Assign Macro, and we'll choose the Run All macro. I'm going to go up to View and turn off my grid lines and headings since I think they make my screen look ugly. I'll go back to User Input. I'll select one particular date, June 9th, 2023, but I'll pick every product, every region, every supplier. I'll go back to Process Data, click the man. There's every product, every region, every supplier, but only for that one day. So that macro updated our selection output tables and refreshed the final output table. I'll go back to User Input. I'll change my end date to December 31st of that same year, but I'll pick one product, one region, one supplier. Over here, we can still see the tables have not been updated because we haven't executed the code. My output table, I'll click the Run icon, and there we have Exercise Machines, Northwest, Sports World in the second half of 2023. So this was quite the journey to solve this problem, but because of the inherent lack of communication between slicers and Power Query, it seems like a necessary evil. It's many steps, it's quite a bit to juggle, but once it's in place, you don't have to worry about it. So remember, tables to pivot tables to slicers, slicers back to data tables into Power Query. Those become filters. Don't forget to download these files from the link in the video description. I've got all the documentation, and if you know of a faster way to do this, put that down in the comments. This was the way I figured it out, but I'm sure there's somebody out there smarter than I who knows a better way. Thank you so much for watching, and remember, at BCTI, the learning never stops.